In this lesson, you are going to be learning about synthesis reactions. The essential question that we're going to focus on in this lesson is, how can I predict the products of a chemical reaction, specifically synthesis reactions? By the end of this video, you should be able to identify the 7 diatomic elements that were introduced in the last lesson, predict the products of a synthesis reaction if those reactants are going to be forming an ionic compound. You will not be able to predict which product would form if it's going to be a covalent compound. And then complete and balance a synthesis equation. A synthesis reaction is defined as any reaction where I start with multiple reactants and those combine to form one product. So you're always going to have more than one thing on the reactant side, but only one substance on the product side. The reaction we're going to start with is sodium plus chlorine forming sodium chloride. The first step is to write the formulas for the reactants. In this case, my 2 reactants are both elements. Sodium is Na, and when I'm writing the formula for elements, I need to remember to double check whether they are one of the diatomic elements or not, which remember contain hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So sodium is not a diatomic, so it does not get any subscripts. Next I have chlorine, which is Cl. That is one of the diatomics, so I need to give it a subscript of 2. Those are my reactants. Next I need to write the formula for the product. Sodium chloride is NaCl. Since it's an ionic compound, if you didn't remember the formula for sodium chloride, you would look up the charge for sodium, the charge for chlorine, and crisscross and reduce those. Sodium is +1, chlorine is -1. Therefore, the subscripts for both would be 1, and those are not written. Finally, we need to balance the equation. Once we have the formulas, we cannot change any subscripts. We can only add coefficients in. If we look at the sodium, I have 1 sodium on the left, 1 sodium on the right. So the sodium looks good to start with. However, there's 2 chlorines on the left and only 1 on the right. So I need to put a coefficient of 2 in front of the NaCl to balance the chlorine. So I've got 2 on the left and 2 on the right now. But now I have 2 sodiums on the right-hand side, so I need to put a 2 in front of the sodium to balance the sodium out also. Next, we're going to look at the reaction between hydrogen and oxygen to form water. Hydrogen symbol is H, and it is one of the diatomics, so I need to write it as H2, plus oxygen, which is also one of the diatomics, so it needs a subscript of 2 as well, yields the formula for water is H2O. All right, those are the formulas for the reactants and products. I cannot change those anymore, but I do need to balance this. I have 2 hydrogens on the left, 2 hydrogens on the right. However, I have 2 oxygens on the left, and right now there's only 1 on the right. So in order to balance this, to get 2 oxygens on the right, I'm going to need 2 molecules of water. That gives me the 2 oxygens I need, but that also changed the hydrogens. I now have 4 hydrogens on the right side, so I'm going to need to put a coefficient of 2 on the left side. 2 H2 molecules will give me 4 hydrogen atoms on the left as well. Next, we're going to look at tantalum plus oxygen. Tantalum is element Ta, which is not one of the diatomics, so I do not need a subscript, plus oxygen, which is a diatomic, so I need a 2. Now it doesn't tell me what the product is, but I know it has to be a compound containing tantalum and oxygen. So I'm going to start off and just write the tantalum and oxygen symbols next to each other. However, I need to figure out what those subscripts are going to be. To do that, we need to look up the charges on the ions for tantalum and oxygen. If you look on your periodic table, tantalum, Ta, is atomic number 73. It is in group 5. And in the upper right-hand corner of the element square, it tells us that tantalum has a charge of +5. And oxygen, you can also look this charge up if you don't remember, is always going to be -2. So when I crisscross those charges, I get Ta2O5. Always double check after you crisscross to see if the subscripts can reduce. 2 and 5 can't reduce, so those will be the subscripts. So I can get rid of those charges because I'm done with that. That helped me figure out what the subscripts were. But now I need to balance this equation. Both the tantalums and the oxygens are not balanced right now. It doesn't matter which element I start with. However, the ones that have no subscripts are going to be easier to balance in the end. The ones that have subscripts on both sides are going to tend to be a little bit more complicated because I can't just get whatever number of them I want to. Since the oxygen's a diatomic, those have to come in pairs. So I have 2 on the left and 5 oxygens on the right. So on the left they come in 2s, on the right they come in 5s. So I need the least common multiple of 5 and 2, which is 10. So to get 10 oxygens on the left, I would need 5 molecules of O2. And then to get 10 oxygens on the right, I would need 2 Ta2O5s, because 2 times 5 gives me the 10. Now if I look at the tantalum, I have 2 times 2, 4 tantalums on the right, so all I have to do is put a 4 to get the correct number of tantalums on the left. Next we have potassium and bromine. Potassium is K, not one of the diatomics, plus bromine, Br, which is a diatomic, forms a compound of potassium and bromine, K with Br. I need to look up the charges on these. K is a +1, bromine is a -1, so crisscross, it's just KBr. 2 bromines on the left, only 1 on the right, so I need a coefficient of 2 in front of the KBr. That gives me 2 potassiums on the right, so I need a coefficient of 2 in front of the potassium on the left as well. The last example we're going to do is iron plus chlorine. And there are 2 possibilities for this because iron can form multiple charges. So we're going to go through both of the possibilities. Iron is Fe, which is not a diatomic, and chlorine, Cl, is a diatomic, so it gets a subscript of 2. Now, since we're going to do two different possibilities, I'm going to write out those reactants again. The reactants are not going to be any different. It's iron plus chlorine in both cases. The difference is going to be what the products are. Now, both products are going to be an iron with a chlorine. However, I need to use the different charges for iron. On the top one, I'm going to use the +2 charge for iron. Chlorine is always a -1 charge. So if I cross the +2 of iron and the -1 of chlorine, I'm going to have FeCl2. On the bottom one, I'm going to use the +3 charge for chlorine. For iron. The chlorine is still -1. So when I crisscross, it's going to be Fe1Cl3. So the only difference in these is going to be the subscripts on the product side. Now I need to balance this again. 1 iron on the left, 1 iron on the right. 2 chlorines on the left, 2 chlorines on the right. This one is already balanced. However, remember this 2 on the left came from the fact that chlorine is a diatomic. The 2 on the right over here came from crisscrossing the charges on your product. On the bottom one, I have 1 iron on the left and 1 on the right. However, I have 2 chlorines on the left and 3 chlorines on the right. The least common multiple of 2 and 3 is 6. So to get 6 on the right, I would put a coefficient of 2 in front and a coefficient of 3 in front of the Cl2 to get 6 chlorines. But I also have 2 irons over here now, so I would also need a 2 in front of this iron. So remember, synthesis reactions always start with multiple reactants and end with one product. If you're trying to predict the product, it's going to be an ionic compound. You will need to look up the charges and crisscross them to figure out what the subscripts are going to be. On the reactant side only, you need to double check and see if the elements are diatomic or not. It's only on the reactant side because that's the only side where you're going to have a pure element. Once you've figured those out, then you're going to go through and put in coefficients to balance. Never look at subscripts when you're trying to balance.